Good afternoon, everyone. It's given me great honor and privilege to stand before you today to extend a warm and heartfelt welcome to each one of you at the UP Session International Conference of Electrical, Electronics and Computers Engineering, that is Upcon 2024, a prestigious platform for innovation, collaboration and the exchange of heartbreaking ideas. This moment become even more special as we welcome a distinguished personality who had made significant contribution to academia, research and professional development in his field. And to start with, I would like to invite a distinguished academician and visionary in the field of computer science and engineering department, Dr. Anil Kumar Singh Sir from MNIIT, Prayagraj. He has been instrumental in advancing research in data analytics, machine learning, cloud computing and cybersecurity. His dedication to education is evident through his supervision of numerous PhDs and MTechs, thesis, mentoring the generation of engineers and researchers. Beyond his academic contribution, he has several key administrative positions, including Head of the Computer Science Department, Associate Dean of Research and Consultancy, and Coordinator of various innovative projects like the Information Security Education and Awareness Project. His leadership in organizing workshops, symposiums, has greatly enriched our academic community. We are honored to have him share his insight and experience with us today. Please join me in welcoming Dr. Anil Kumar Singh Sir with a huge round of applause.
Very good afternoon to all. Is my voice clear? The audience is not much. If it is not reaching and echoing, then you can come forward to the other side so that we can talk. Fortunately, they are satisfied. May I have the pointer, please? Okay, well, thanks for, because this is post-lunch session, right? It takes effort to sit in a talk, right? So first of all, I would like to thank the Director Sir of the Institute, Dr. Bhavesh Chauhanji, for inviting me to this prestigious UP Section conference. This is the 11th conference. It's a wide spectrum conference, right? You must have seen the call for papers, right? So what I will be talking today is regarding green computing, right? You have all been using tools which are the present day, you can call them miraculous, right? Which were not present earlier. So if we look forward, how would it look like 10 years from now? And how did it look like 20 years or 2 decades or 3 decades? Or even entire century back. If we talk about industrial revolutions, right? So it all starts with the steam engine, right? 18th century. Then the mass manufacturing started. Okay? Then came the oil and gas and electricity, 19th century revolution with development in telegrams, telephones, right, which created huge impact. Okay. Then it took another century when the computers came in, right. So that was third revolution, industrial revolution, with the advent of more smarter communication technologies. Now you all are presently in the fourth revolution, right, where you are witnessing smart manufacturing. So how does it happen? That is when we call it smart manufacturing, or smarter applications are coming day by day. You are the user of those applications right now. Knowingly or unknowingly, you have got a huge data footprint. Today, your presence is the data, your absence is the data. In this workshop and in the stock, the artificial intelligence, the term which you are hearing and which has creating impact, huge impact, not even on the social front, but on the manufacturing. That is the fourth industrial revolution, right? So when does it all started actually? It's not new. It's in 60s, 1960s, when it all started, when the term was coined as artificial intelligence, right? So the machine, to make machine capable, to make machine more intelligent. But which machine do you call intelligent? Given a machine, you know that you are using a smartphone today, you call it a smartphone, right? Because it has got certain intelligence. You are using n number of applications which are intelligent applications. So if somebody asks you that which machine is intelligent machine, how do you come to assess or know about this? Any idea? So there's a test on the name of one of the most prestigious scientists, Turing, Alan M. Turing. The test was framed as Turing test. Turing test was designed to assess that the machine is intelligent or not. So on the one side of wall, let's say a person and a machine is sitting, and the other side of the wall, another person is there. If you ask questions to the wall, and if it is not possible to distinguish that whether the machine has answered the question, your question, or the machine or the person has answered the question, at least 50% of the time. So that was a test. How long did it take to clear this test for one simple program? It's interesting to know. Eugene software that was written in 2001 but actually came and passed the test in 2014. To pass that Turing test, to make it an intelligent, to be called as an intelligent application. A decade before, Google Translation, or any other tool which you are using very much today, successfully, most of the time, their precision or their accuracy was too less, right? If we call it today that Google is translating it with 90% of accuracy, few years back it was 60%, 50% of accuracy. What made this possible? Then we'll take you to the journey that what is the cost which we are paying for that, right? Well, that's the gist of today's talk, that is green computing. It's what AI can do for green computing and what harm it is causing to green. Right? Because every advantage which comes to the society comes with a price. At least we should understand that price. Right? So if we are aware, then we can take actions for reducing that price. So this is the outline of the talk. So what is an AI and towards the green computing, green AI, and then we are talking about a little bit the latest towards where the AI is going, and some closing thoughts. So I said that it is way back when it was first coined by John McCarthy. But it has never been a success for so long time. There were efforts. It is the first expert system which was developed as MySyn, that was used to develop to assist a doctor, right? So that when we go to a doctor and we tell our symptoms, the doctor diagnoses, right? So the expert system was developed to diagnose the patient, right? That was called MySyn, that was the first expert system. But it was not a success. Today, you must have read the stories, if you have not experienced, that there are applications which in almost in every domain of engineering, society, which says that, okay, these are success stories today. Whether it is a machine doing an operation, or whether it is assisting you with some translation or some formulation of an application, whether it is lawyers or doctors or engineers, there are applications which are assisting you intelligently. The first question shall come to your mind, that what was the reason for artificial intelligence took so long to succeed? Yes, it can be the answer that, okay, the compute is more, the ability to compute is much higher today. We have got more powerful processors which process the data, right? So that intelligence can be brought in. But that's not the only compute. The real reason is, the real driving force is data, right? And the capability to store the data, then came the capability to analyze the data, and this made things moving. And then became, मुझे पानी दे दीजिए. One more thing, that if I ask you to tell your machine that this is your name, this is your phone number, very easily you can do that. You know, at least You have done, all the computer professionals and other people also have done it. That giving information to the machine is easier, right? But if I ask you to tell the machine that if this piece is dropped at this height, it will fall down and it will break. This simple principle we all understand as a human being. They just start thinking that how to teach this simple principle to a machine. The moment you bring the difficulty of teaching, this is an intelligence, right? Which we as a human being have understood very well, very easily. But the moment you try to teach it to the machine, making rules for that becomes difficult. That was one possibility. At least the scientists understand this reason, that this was one reason which made so long to reach to this place. Then came huge data and the capability to process the data, which made it possible because the data itself now make it learn. So rather than making rules, you show so many instances, right? If you are making a machine learn an apple, so give the machine hundreds and thousands and millions of fruits as images, as inputs, so that the machine learns this is fruit and this is apple, and this is another fruit and this is this. So it learns from the data, and that's how the things are moving fast, and the capability to process the data. But when we talk about capability to process the data, see, almost in every domain we have got artificial intelligence applications. Huge data, capability to process, then you process it. And what does it require? Compute. Compute requires energy. Lot of energy is required. You must have understood, at least in the times of crisis when the COVID period happened, that what is the value of fresh air? What is the value of oxygen? What is the value of water? We need to understand that there are cities which are crippling with the pressure of having fresh air and fresh water to drink. And when we use lot of power to drive such compute engines, right, it emits lot of carbon, right, to make your world a little less greener. So what are the ways to make it more green? You cannot lose the advantages which we are getting from developing more complex applications. So almost every agriculture, construction, manufacturing, wholesale, transportation, information, stock, any industry, you will find artificial intelligence have taken a larger domain. This is it visible to you? At the back end it might not be visible. This is a Google Travel, which you can use for booking airline tickets. I have used this as a snapshot just to emphasize one thing, because other portals which we use for booking air tickets do not reveal this information, right? So if we fly from one place to another place, it was a flight which was understood from Gorakhpur to Delhi, non-stop, one particular flight, and along with the details of the flight you can see that how much average carbon emission is going to happen with this flight. So this the industry is doing, at least responsibly, which all other industries shall do, but unfortunately they are not doing it, which at least will make us informed to take decisions that how much we are contributing to it. How much we are part to it at least, party to that. So, 62 kilogram of carbon emission. Right? So what is green AI? AI requires, as I told you, that it requires vast amount of energy. Right? So a lot of carbon emissions are happening. This is alarming. Mind it. Look at the study. The study says at MIT that the energy consumption by ML models to reach over 21% of the world's total by 2030. 2030 is nearby. So that much energy of the total energy is going to be consumed at least by the ML models. And this we are talking about. This we are not able to see that how generative AI at least is going to take part and transform our lives. I'll come to that. How it is transforming it. So let's develop, at least let's start talking about tools which can somehow address this concern. Tools and technologies or techniques to mitigate, because we cannot leave it, right? We have to learn ML models and we have to run it. But how to mitigate, how to at least slow down? What we do? We have to reduce our consumption to reduce carbon emissions, right? As I said, that Google Travel is giving you this information. Others are not talking. We have to talk at least. People aren't talking enough. None of the big tech companies are going to tell you how much they are making your world less greener. Right? We are using it, we are happy. Right? But we should be concerned. That's what I would like to focus today. Common carbon footprint benchmarks. When you look at and said that training one large AI model can emit more than 626,000 pounds of carbon dioxide equivalent, which is nearly 5 times the lifetime emission of the average American car. 5 times. The lifetime of an average emission car. And it is running one ML model. And there are millions of such models are running today. Right? So that's what we need to understand. So these are the estimates. And typically, the generative AI is using transformers. And look at the estimates the transformer is producing today. That is what we are talking about. So what are the key pathways? Right? How to mitigate, how to at least start understanding, right? As a computer professional or as a professional in other domains, when you use such, adopt such technologies, you should be concerned, right? So first point says that adopt next generation infrastructure more efficiently. If we adopt it efficiently or smartly, we can do it. Right? Look at this diagram. This diagram represents the dissipation of heat. Because you must have observed, you using a laptop, it creates heat. If you put your hand towards the fan side, go towards the back of a server, it produces more heat. Go towards the back of an HPC cluster, it produces enormous heat, which we need to cool. So cloud centers typically produce a lot of heat, abundance, which we need to cool. उनको ठंडा रखना है नहीं तो वो चलेगी. So you need lot of energy to cool it. And it is producing heat. So can we channelize that heat to those to those industries where the heat is required, where you use other sources of energy to generate heat. So this diagram shows that the energy which is produced from a cloud data center typically is being channelized to other places so that it can be reused there. We don't need to produce the heat again by using other energy sources, right? Is it the visibility? So implement advanced cooling systems. This is happening at one of the Microsoft data center, जो कि Helsinki में है. And this is an actual photograph, right? Of the way it is being implemented by Microsoft at Helsinki. See, when we use a lot of energy and the energy is produced in a greener way, okay, you can use it. There are only few countries which are producing energy in a greener way. Unfortunately, we are not one of them. We are not using methods to generate energy which is more green, right? So we have to be more concerned. So one is this channelization of heat which is happening. The other is the intelligent use. Sometimes we keep our machines on, right? We are not using it, but it is on. Similar thing happened with lot of virtual servers on cloud centers or servers even. So there are a lot of research is going on which consolidates the virtual machines on a cloud data center, right? Because those who are the user of cloud data centers must have used virtual machines over cloud, right? As per their requirement. So one machine running 2 virtual servers and the other machine running 5 virtual servers, which has got the capability to run 7. So you can shut down this machine and transfer the virtual machine to another, which can be done easily. Right? You will have to adopt the mechanism to consolidate the task, to consolidate the virtual machines. And shut down the servers which are called zombie servers. Kuch log kar rahe hain. This is image I have taken from Lincoln Laboratory, a photo given by some person. So MIT Lincoln Laboratory is developing techniques to help data centers reel in energy use. So typically, the tool that was suggested and adopted by Microsoft was suggested by the Lincoln Laboratory of MIT. See, this is an important aspect because when we adopt any tool or technique to mitigate the carbon emissions, the performance should not be affected. Because we do not want to lose the benefits of the AI which we are reaping today in almost in every aspect, right? So it is suggested that it is observed that these tools have much minimal effect. The second key thing is shifting to cloud computing. First, we'll talk about this, right? Rather than managing our whole infrastructure locally on premise, you can shift to cloud data centers which are more equipped to adopt the tools and techniques for mitigating the crisis which we are talking about. Right? And using cloud resources as compared to on-premise resources has got immense benefits. You must have read about those. We can discuss about those. So a company would cut carbon emission by at least by 15 to 20% by doubling their investment on existing infrastructure to cloud, rather than maintaining their whole infrastructure on-premise cloud, which earlier we used to do. Because all public cloud service providers, whether it is Microsoft or Google or Amazon or other players, they have got in use at least some techniques which reduces the carbon emissions. Third solution goes to shifting to edge compute, right? Because see, when we are using cloud, we move all data from the endpoint devices, whether it is your automobile, whether it is your phone, or whether it is your any other sensors, to the cloud for being processed. तो आपको क्या लगता है कि डेटा अगर आप अपने डिवाइस से क्लाउड पे भेज रहे हैं, वहां पे एनालाइज हो रहा है, तो सेंडिंग इटसेल्फ रिक्वायर्स लॉट ऑफ एनर्जी, right? So can we do compute on the edge devices, because you have got very powerful devices in your hand. The phone which you are using is very powerful, right? So doing compute at the edge of the network, that is at the initial point of the network, before sending the data for the analysis to the cloud server, is the new norm, right? So moving to edge rather than to the cloud, that is edge computing is well positioned to address these reasons. So adopt computationally intensive AI models, because edge devices are normally low in hardware. They are low cost also, low energy consuming devices, right? So if we can develop models which can train, which can learn on the edge device before moving data for further analysis to the cloud, that would be a beneficial aspect. Okay, when we do problem solving, any problem you solve in your life, whether it is a problem for a computer professional or whether it is a problem for a textile engineer or an automobile engineer, right? We adopt certain problem solving methodologies, right? For a computer professional or for anyone at least, understanding the problem becomes the first priority. Unless you understand the problem, you cannot solve it. Understanding to the sense that you can be able to represent the problem, right? Because representation would ask you to adopt a layer of abstraction for solving that problem. कभी सोचिए अपने आप से कि भाई किसी भी प्रॉब्लम में दुनिया में आपने जो अपने जीवन में देखी, whatever you have seen in your life, there are some people who are very good at solving those problems as compared to some other people. Simple problems. If you need to select one phone which to buy, ठीक है, कुछ लोग हो सकते हैं जो faster decision ले सकते हैं. There are people who cannot decide even for 10 days or 20 days or even a month which phone to buy, and which is a very simple decision, right? It's not actually a problem. They can have any other problem, right? So why some people are good at it, some people are not so good at it? Have you ever thought? It's not your mental capability to, because almost Everybody possesses that level of mental capability to solve that simple problem. It's not about this problem. Not solving a very complex scientific problem. Simple real life problems which we handle every day. दोबारा से सोचिएगा इस विषय में और उसकी वजह है the reason is that you are not able to represent the problem, you are not able to understand the problem. The moment you are able to represent the problem well, because that representation would require you to settle down at a certain level of abstraction. You look at the problem above that abstraction, उसके ऊपर से देखते हैं, and whatever is below that is hidden. You will not be able to work on a system, on a computer, if you are asked to worry about that how the data is flowing from register to memory and from memory to being processed and sending back to disk. Don't bother. When you don't bother how the data is stored in your disk, which file system is being used. Because you are at a higher level of abstraction, so that you are able to use it. If you come to the lower level of abstraction, it becomes complex for you. It might not be. You might be afraid to use it. Right? That's why it happens that some people are good at solving the problem, some people are not so good. Here comes the fourth key point, which says that, okay, well, we are running ML models, it requires energy, we need to use that ML model, we have to run it. But can we do it intelligently? Can we do it with better algorithms? Have you ever confronted yourself with that this algorithm will take more compute as compared to this algorithm for doing the same task? वही काम करना है, ठीक है ना? आपको point A से point B पे जाना है, you can use the shortest distance, you can use the other distances as well. So if you use the shortest distance, the energy expenditure is less. और अगर आप लंबे रास्ते से जाएंगे तो ज्यादा खर्च होगी, सिंपल सी बात है. So if you have got algorithm which takes more compute, employs more energy, produces more carbon, which we don't focus. So developing algorithms, or designing algorithms from a systematic view, which says that you can choose algorithms which are consuming less energy, right? So tree-based models with sparse features better than neural networks and deep learning could serve as alternative to mitigate the energy use. Because then we need to understand what is tree-based models. So those who are from the computer science background can easily understand this. Okay. Then ensuring the efficiency and circularity. Circularity is reusability. वो हमें अपने लाइफ में भी यूज करें. We as a responsible citizen need to adopt techniques, tools which are used, right? Even objects which are not used. If you buy a pair of shoes every year, okay, you have got the capability to buy a pair of shoes, but for manufacturing that pair of shoes, lot of energy has been spent. Mother Nature or Mother Earth is not ready to bear that. Okay, that's a simple, very simple example, but you can ensure the efficiency and circularity of the components of physical assets, which most of the industries are now doing it. Zero-based goal in managing cloud hardware, because electronic waste is becoming a challenge. It's a huge challenge. Right? And that's creating concern. The last point which I would like to touch today is the next generation AI towards which we are leading to. That is generative AI. How do we differentiate? What differences you see with AI and generative AI? With AI, typically, we make model learn, right? And predict. Is it? How do we make model learn? We make model learn with data, right? Whatever data is there with the ground truth, हमें पता है कि एप्पल है, हमने मशीन को पता है, हमें पता है कि एप्पल नहीं है, हमने मशीन को पता है. Machine understood that इस तरीके की जो चीज दिखने वाली हो, एप्पल है ऐसे दिखने वाली है, नॉन एप्पल है, and so on. Done. Simple. This is AI, fine. But it is not producing anything new, right? It is not generating, right? Can it have the capability to generate new data itself so that something more interesting can be learned, which was not there earlier, right? Something more interesting would be there if it generates on its own. That's where we are heading towards, using generative AI, which says that machine learning model that is trained to create new data rather than making a prediction about a specific data set. ChatGPT must be using it, right? It's 4.5 version which has been rolled out. Must be using 4.4 version at least. And your phones, it's a tremendously powerful tool. And it's not only ChatGPT, Gemini by Google and a lot of other companies are coming with their generative AI models. Microsoft has got its own tools, right? Copilot. So, and they require even more compute as compared to the AI models. This orange part is the development in 2024 in different sectors, which has been taken over by the generative artificial intelligence models. Right? So it is automobile, customer services, strategic analysis, product innovation, supply chain, logistics, sales. Prior to 2024, it was the percentage is represented in blue, right? At least you can see the differences in the growth in color, that how fast it is growing, at what alarming rate. It has got huge potential. We are looking at it. We are observing it at least. Not only to reshape key business operations, but also to shift all type of competitive landscape. So, how to make generative AI greener? Similar types of tools and techniques have been suggested for its adoption by different laboratories which are working. Even one of the pioneer laboratory is Lincoln Laboratory of MIT, which is using on this. So what are the quick wins today? Switch to cloud or consider edge computing at least. Right? Improve the algorithm, explore more eco-efficient cooling methods, source renewable power, the energy is needed, source green energy rather than the traditional energy generation mechanisms. Establish the capability to better measure emissions and inform the people. Better measure emissions. We are not able to measure even, right? We don't know. carbon which we are contributing and buying a new pair of shocks because उसको बनाने में कितनी एनर्जी है, कितना कार्बन है, you're not aware. Don't bother. Then comes the government aspect, which to set proper policies and incentives which various governments are doing, and that's the closing thought for today. We have talked about. So that, with that I came to end of this talk. Any questions we can take or a quick discussion before wrapping it up?
Any question, please?
Well, since it's not exactly a question,
Okay.
but a thought, I can say that your discussion has at least enlightened to this aspect, because the world and India is embracing AI a lot, and we are also having certain sustainable goals. At the macroscopic level, I am able to see the quick wins, as you have just said. But at the microscopic level, how are we going to implement it actually when AI is being implemented at a rapid pace? I think that is a little bit of challenge.
That is really a challenge, right? But at least we should be, first of all, concerned about this issue, right? If we are concerned about this issue, we start looking at the alternates which are being, at least if we are not doing a research in that direction, which are being suggested by different researchers, right? With different labs, that is some of the tools and techniques that I attempted to suggest. Of course, they are not for a common man to be adopted for reducing the emissions, right? But at least the common man should be aware of its own footprint, carbon footprint, right? And it's true that once you are aware, you'll make informed decisions, right? That's what the effort is.
Any another question, please? Anyone? I think it's a question.
So thank you for hearing me patiently.
Now, we extend a heartfelt thanks to Dr. Anil Kumar Singh sir for his enlightening session. The valuable insights shared have truly enriched our knowledge and inspired us to explore further in our fields of interest. Now, I would like to call Dr. Sunil Kumar sir to come on the stage and guide us for the further event.
Thank you. So, our next event will be inaugural function, and that will be scheduled in the seminar hall. I already practically जहाँ पे गए थे. So now I request to all the guests and presenters, authors to move for the lunch in the seminar hall on the same place where already we have taken the high tea. And after that, inaugural function is scheduled on the seminar hall. Right? Thank you everyone. Also, I request to students, please guide our guests.
ऐप ब्लॉग है सब पीछे से क्या है इधर पीछे इधर से अंदर से कोई नहीं तो बंद है
मत करो तुम
मैं डिलीट कर दूंगा
नहीं मत खींचो मेरी मत खींचो मेरी मत खींचो
First take your lunch and
कुछ हो बंद कर
वो निकाल लो
निकाले